Here we're talking about mechanism of nucleophilic rearrangement reactions. Nucleophilic rearrangement, broadly, these reactions consist of three steps. First step is the generation of electron deficient center in the molecule. As the migrating group migrates with electron pair, migration terminus must have an incomplete octet. This can be obtained in two ways. Through carbocation. Carbocations can be formed in various ways, the most common being dehydration of alcohol. This step is similar to that of SN1 or E1 reaction. These reactions show such an example where an alkyl halide is giving SN1 reaction and removing bromine from alkyl halide to form a carbocation, and after that rearrangement is happening. Two types of product are formed when rearrangement occurs. After rearrangement, the molecule could deprotonize and give a olefin. Or another thing could happen where hydroxyl group can attack on the carbocation, which would form a tertiary alcohol. Rearrangement of carbocation is very important reaction in cracking of petroleum product as shown below. Here this molecule here is given acidic medium, which results in the formation of a carbocation, which gives an alkene as a result of rearrangement reaction. Through nitrines, nitrines can be formed by decomposition of acyl azide. Following is an acyl azide, which removes a nitrogen gas, and the resultant is a nitrine. Migrating group migrates to the electron deficient center with its electron pair, creating a new electron deficient center. In third step, newly formed electron deficient center acquires octet either by accepting a nucleophile or excluding a proton, as we discussed below. It is observed in many cases that either two or all three steps take place simultaneously. As seen in many cases, SN1 type of first step is commonly followed by rearrangement to give a more stable cation. It is proved by the fact that rate of reaction increases with the ionizing power of solvent, and it is unaffected by concentration of base. It has been shown that the rate of migration increases with the decrease of electron deficiency at migration terminus. Nature of migration. Migratory rearrangements are intramolecular. Crossover experiments are useful tools to establish the nature of migration. Another form of evidence can be gathered by using chiral migrating group. If configuration at the migrating group is retained in the product, it is likely that the rearrangement is intramolecular. In this example, inversion at migration terminus take place. The reactions involve diazotization and intramolecular 1,2-phenyl migration. These are a few examples. The first one is a Beckman rearrangement, where it is shown that only anti group present anti to hydroxyl group, like the one which is present at transposition to hydroxyl group, would show the mechanism of migration. And following are two examples of migration: general, and in this case neighboring group assists the departure of leaving group, which in turn can increase the rate of reaction.